Hey everybody, this is Rhett. Welcome to Statistics. In this video, we'll learn about measures of center. The mean is one measure of center. In everyday usage, the word average is often used to denote the mean. To find the mean of the values in a data set, add up all the numbers and divide by how many you have. In Excel, you can use the function average. Recall that there is a distinction between a statistic and a parameter. A statistic is a numerical summary of a sample. The sample mean is called x bar and can be written as x bar equals sigma x over n. The Greek letter sigma indicates a sum, so in this formula we're supposed to sum all the data values, x, and then divide by n, our sample size. A parameter is a numerical summary of a population. The population mean is called mu and can be written as mu equals the sum of all the data values divided by the size of the population. Another measure of center is the median. Half the data values lie below the median, and half the values lie above. If the sample size is odd, then the median is the middle value when the data values are placed in order from least to greatest. If the sample size is even, then the median is the mean of the two middle values when the data values are placed in order from least to greatest. In Excel, we can use the function median. A third option for a measure of center is the mode. The mode of a data set is the data value that occurs with the greatest frequency. Data sets with more than one mode are multimodal. In Excel, we use the function mode. If a data set is multimodal, Excel will return the smallest mode. Let's look at an example. Here's a small data set consisting of the data values 1, 1, 2, 3, 5, 8, 13, and 21. The data values are already in order from least to greatest. If we consider this to be a sample, the mean of the sample, x bar, is the sum of the values divided by the sample size. In this case, we'll add the values and then divide by our sample size, which is 8. We end up with 54 over 8, which is 6.75. So the mean of the sample is 6.75. Since the sample size is even, the median of the sample is the mean of the two middle values. In this case, the two middle values are 3 and 5. So we'll add these together and divide by 2, and we find that the median is 4. The mode is the most frequently occurring value. In this case, only one value repeats, 1. So the mode is 1. We have a sample mean of 6.75, a sample median of 4, and the mode of the sample is 1. Let's consider how skewness affects the mean and the median. The mean is not resistant to extreme values. For a right-skewed distribution, the mean is larger than the median. For a left-skewed distribution, the mean is less than the median. And for a symmetric unimodal distribution, the mean, median, and mode are fairly close to one another. Let's consider the data set from the previous slide. In this case, I've changed the last value from 21 to 121. How will that affect the mean and median? Recall that the mean was 6.75 and the median was 4 before I changed the last value. Now, the mean has increased to 19.25, but notice that the median is unaffected. It's still 4. The median is resistant to extreme values, while the mean is not. So an extreme value has an effect on the mean, but not the median. To further illustrate how skew affects the mean and the median, let's look at some data on CEOs of small firms. Forbes magazine published data on the best small firms in 1993. The data extracted are the age and annual salary of the chief executive officer for the first 60 ranked firms. These were firms with annual sales of more than $5 and less than $350 million. Firms were ranked by 5-year average return on investment. Here are the ages of the 60 CEOs. The mean age is 51.47 years. You might say that the average age is 51.47 years. The median age is 50 years. So half the CEOs are 50 or younger, and half the CEOs are 50 or older. The mode is also 50 years. So the most frequent or common age among the CEOs is 50 years. Here's a histogram to illustrate the distribution of CEOs by age. Notice that the shape of the distribution is bell-shaped. The distribution is roughly symmetric. There's a single peak in the center of the distribution. So this is a symmetric unimodal distribution, and the mean, median, and mode are fairly close to one another. Here are the salaries for the 60 CEOs in thousands of dollars. The mean salary is $404,000. The median salary is $350,000. Half the CEOs make $350,000 or less, and half of the CEOs make $350,000 or more. The salaries are multimodal. Notice that $250,000 repeats, as does $291, $298, and actually there are several others that repeat. Here's a histogram to illustrate the distribution of CEOs by salary. The highest bar corresponds to a count of 18. This is the highest count, and in a histogram indicates a mode. Notice there's a tail on the right-hand side, which indicates that this is a right-skewed distribution. And for a right-skewed distribution, the mean is larger than the median. We see a mean of 404,000, which is larger than the median of 350,000. The mean, which is not resistant to extreme values, is inflated by a few large salaries. In this case, one CEO had a salary of over $1 million. This one salary inflates the mean, but does not affect the median. So, which is the best measure of center? Each serves a purpose. Consider a data set that represents departure delays in minutes for the 1 p.m. flight from Atlanta to LaGuardia. 2 weeks of data might look something like this. If you were booked on the 1 p.m. flight, would you rather know the mean, the median, or the mode of delays for the past 2 weeks? The mean delay is 15 minutes. The median delay is 1.5 minutes. And the mode is no delay. When we look more closely at the data set, we see that on one day the delay was more than 2 hours. However, on most days there's no delay. In this case, you might want to know the mode, the most frequently occurring value. What if you're in the market for a new home and a particular neighborhood is of interest to you? You might want a summary of home prices in that neighborhood. Here's a data set that contains the recent home sales prices for 14 homes in a particular neighborhood. These are in thousands of dollars. The mean is $242,000. The median is $192,500, and the mode is $188,000. Which of these is the best indication of center? Notice that the mean, once again, is inflated by an extreme value. One home sold for over $800,000. The median tells us that half the homes sold for less than $192,500, while half sold for more than $192,500. The mode is the most frequent sales price, but in this case, it only repeats once. I think in this case, you could make an argument that the median is the best measure of center. Finally, let's consider scores on a biology exam. Here are 14 scores on a biology exam. The mean is 79, the median is 80, and the mode is 81. This distribution is unimodal and roughly symmetric. There are no extreme values, and so the mean is a good choice as a measure of center. In this video, we've looked at measures of center: the mean, median, and mode. We discussed resistance and how skew or symmetry affect the three measures of center. Thank you for watching and have a great day. Until next time, stay real and be rational.